Hello, I'm here. I was not listening for a second.
No worries. You also have the opportunity to chat later. Just wanted to acknowledge your
One,
presence.
good luck with the presentation.
I'm not sure, is it from my side or is Yosha breaking for everyone too?
Yeah, I couldn't hear him properly.
Okay, thank you for the feedback. Good morning, everyone, and welcome to Cohort 9 Demo Day. Today is week 15, and it's been a huge pleasure and honor to be on this journey with you, learning about machine learning and data science since July. Actually, our very first meeting was July 26th, and today is November 1st. So this has been over 4 months of learning together as a community. So thank you for sticking through, for being here, and for all of the hard work you have put in since the very first day until today, and the hard work you will continue to put in to advance your career. My name is Tejumade Afonja. I'm one of the organizers of Cohort 9 and also the co-founder for AS at the Lagos community. I have structure today's agenda as follows. I will be your moderator throughout, but I also have my team here on the call where who would be, jumping in to share thoughts or to review your project. We have judges here for the different teams to give some feedback, and also I hope that we would have enough time to have like a longer discussion, just like a reflection of the entire cohort. Also hear from you what you would like to do next and how we can continue to support your journey. So from 10 to 10:30, which is in about 15 minutes, we plan to have like an introduction telling you about AS at the Lagos and mission and vision again, just as a way to wrap up the cohort. Then I'll talk about the presentation slides, briefly just introduce the different talks we're going to have today, and that would each talk will last for 10 minutes with 5 minutes question answering and discussion. We would have that for roughly from 10:30 till 12, and then we will conclude today's meeting with the reflection and next steps. Okay, so who are we? We are AI Saturdays Lagos. It's a free to attend our community-driven initiative. We have been existing since 2018, and we are focused on democratizing AI knowledge across Africa. We do this through teaching, our teaching classes, which we're part of right now. Research, we also have a research cohort plus participate in research. We do projects and also innovation. So our hope and aim is that the teaching and the research become an innovation that would serve our community and beyond. And we especially like the slogan, which is that a candle loses nothing by lighting another candle, which is what we think we're doing right now. By lighting your candle, our candle also continue to burn, and we hope we all burn together and shine brighter together. Um, so our goal here really is we want to build AI presence within our community and other African AI communities as well. And we want to stir up the spirit of innovation and problem solving amongst our African youth. And we want to encourage peer motivation And this is why AS at the Lakers learning together for 16 weeks of classes spanning over 4 months. It has been one of the things it's what we are known to do. And we will continue to do in the future, we hope. So we provide the resources, we reach out to educators across the continent and beyond, to teach you about a lot of this concepts in machine learning that you would like to learn. So we structure the classes in form of say introductory class to machine learning or data science, or we have introductory classes to deep learning, or like some cutting edge methods, like advanced curriculum, like say transformer neural network, which we hope would be our next cohort. So stay tuned. Our values is have this acronym ELECT, which is excellent leadership. We lead with empathy. It's very important for a community. Collaboration. We have the spirit, and then we try to be as transparent as we can. And if you have not done so already, highly encourage you to join our Google groups. That's where we share a lot of information with the members of our community. Okay. In addition, to support our mission, we would like to encourage you to, give us a star on GitHub for all of our projects. We have the code structure there. On Twitter to follow us, and same goes for the other social media platform like Instagram, LinkedIn, and please like, subscribe, and watch our educational videos. So the co-organizing team that has been the brilliant minds behind the S of the Lego since 2018 are these phrases that you see here, but I will name them. So we have my co-founder Femi, was to my right, and then I have my amazing friend, co-organizer, and also co-founder for the NGO that runs AS of the Lagos, Kenichi. Um, we have Ghana was also co-organizer. I smile when I mention their name because I've known this everyone here for 6, 7 years now, so it's pretty special family. We've built together. We have Tayo Jabar and Icon Tola. And I have here Stanley Duco, Lawrence, George. I have my very good friend here, wherever. And we have Simon to the right, and then I'm blanking now. I will come back for a second. So would anyone who's on the call like to say hello to the team? Lakon. This is Lakon. I'm blacking out on Lakon's name. It happens sometimes, so I'm not surprised at myself. Um, would anyone like to say hello?
I still have to tell him about school fees. You tell me I should choose one.
Oh, sorry. Joy got unmuted.
Um, Hi everyone.
Hi.
My name is Tayo. Always happy and lovely to be here. Can't wait to see all the presentations. I think the projects are interesting. I've been taking an initial look at them, so I'm looking forward to hearing all of your presentations. And at the end of the day, having a good time.
Thanks, Tyra. we also have Kenichi on the call and Tola, right?
Yeah. Hi, people. Good morning. I'm happy. I'm happy we're here. I think I remember when I taught one of the classes. Super excited for those who have made it to the end, right? But as usual, I will always say it doesn't end here, right? I really want to see how you apply all the things you've learned into projects that you're going to do, startups. I'll also want to see that some of the projects that are here become something big that would make every one of us proud, right? So it's we call it a community, but it's a movement, right? Let's put ourselves on the map. Right. Thanks.
Thank you, Kenichi. George, Tola, would you like to also comment?
Hello, everyone. My name is George Ikpebe, and I'm one of the co-organizer, or I can't remember. Just pick one and run with it. So it's an amazing time to be here, and I'm actually excited about these demos. And the little I can say is the fact that you actually got to the final stage or got to the last week of demo. It means a lot, and for me, I've gone through this process and thinking about it, reflecting on it, I think is something worth doing. And you never can tell. It might actually be one of those things that you're going to do in the next couple of years. When you look back at it, you will reflect like it's an amazing thing that you did. But congratulations to everyone that have gotten to this stage. And I can't wait to see what you guys have done.
Thank you, George. Tola.
Hi everyone. Okay, so I looked at the list of the projects and they are really, really interesting projects. And I'm really proud because I was here on the first call of this cohort, and the first few calls, a lot of people had a lot of doubts and complaints. I'm really happy that we are here at this point, and I cannot wait for the amazing presentations I would see today. Well done, everybody. Good luck. I wish you all the best.
Thank you, Tola. Okay, I think those are all the co-organizing team. I see you on the call. Okay, about the cohort 9, I would like to invite Yomife to walk us through this because he was the cohort lead.
Yeah, hello everyone. Yeah, my name is Yomife once again. It's Yomife Doali, Yomife for short. It's been a privilege working with the community and bringing this cohort to life. It's been a privilege to serve as a to serve with AI Saturday. I am glad. I'm glad about the privilege. Thanks so much. Yeah, this cohort was that we decided to bring a bit of switch to this cohort and make it a flipped cohort rather than the physical ones, because we have the materials from the previous course which are still very much relevant, and we decided to like incorporate it into a flipped cohort, and here we are today. So we ran 10 weeks of lectures, 10 weeks of structured learning. Yeah. We sent materials to participants at the beginning of the week, as well as assessments. And we take assessments and also like track the assessments that students, the participants like they did. So yeah, and then afterwards we also they picked teams and they worked on projects together. Here we are today. Can you see the next slide?
Thank you so much, Yomife. So this is it's a flipped classroom kind of cohort where participants every Saturday come together with Yomife being the lead, talking through the material that they have studied over the course of the week. And it has really been very interesting. It's the very first time we ran a cohort in this format, and I hope to hear from you at the end of the like towards the end to hear what you think about it. If you would like to have this kind of format again in the future, or what was the downside, upside, what was the material like for you? So we'll leave some time to discuss that. And just a quick one to mention is that everything about the cohort is in this cohort structure GitHub page. You can read about it. You can look at the different classes that we run. But for completeness of this slide, I would like to come here. So we each week we had different materials. So on the first week was the onboarding. Then we had the Python numerical computing, and then we had the data science foundation material, which introduced you to data science and also data collection and scraping. Next, we had the relational data week, where we also looked at visualization and data exploration. Then we proceeded to the mathematics for machine learning week, where we talked about linear algebra in detail. Also, that week we had a guest instructor, Kenichi, walk us through the lectures. And then we had the week on text processing, which was on free text and natural language processing. And the following week, so that week was when we asked you to submit your project proposal. And the next week to that, which was what we call week 6, we had linear regression and classification model, where we introduced you to machine learning and linear regression and also linear classification. Then on week 7, we had nonlinear modeling and interpretable ML, where you looked at like techniques like cross-validation and also algorithms for nonlinear modeling and also decision tree algorithm. Then you proceeded to doing probabilistic models and learning about basics of probability and maximum likelihood estimation. And then you worked on unsupervised learning and recommendation system. And I believe the same week we had a guest instructor, Femi, that talked to you about how to deploy models. So you did a lecture on model deployment. And so you also learned about recommender system here in this in the week as a material. Then the last week we talked about deep learning basics, where you were introduced to deep learning. So these were all of the what the week looked like for you. It was very packed weeks, and we hope you were able to watch the videos that were sent to you, and all of those videos are of course still available on YouTube for you to catch up on them. And we also have added all of the weekly community call that we had is also available on YouTube. So on this link, you will find all the weekly community. On this link, the previous link, you found the videos that we shared with you from the cohort 8 lectures. And then the second week is the weekly community meeting calls that we had. So, and in addition, like Yomife said, we had assessments every other week, which you participated in. And then the project is why we are here today. Okay, so I think I'm on the like it's now 10:30, which is when I wanted us to start the project. But we promised you that by the end of the program, you will not only understand how ML works, but you would have built real projects to be able to add to your portfolio. And today's call is a testament to that promise, which you have really been the driver of, and you have showed up with projects. And we're very, very proud of all of the proposal that you submitted. So it's very interesting to read about the ideas. So we received 11 proposals. across the 11 teams that were formed. Each team comprises of members from 2 to 5 people. And, we had project proposals like how do you predict customer churn in Nigeria telecom industry using the MTN data as a case study? Or like how do you cluster research paper, discovering topics from that and organizing literature, which is a very important project because me as a researcher, I would like more tools to help me become more efficient in reading paper and discovering works. So we also had another very interesting proposal out there, Seed Guard AI, where the team was concerned about mapping genetically modified organism narrative landscape for to empower agricultural sovereignty. It was like it came from the observation from some of the team member that a lot of the we're now having a lot of GMO seeds, being unintentionally used by farmers and may even have like a damaging effect based on some some observation and it was like a very important discussion to have. Do you know what kind of seed that was planted and then you're eating? What kind of effect does it have for your body? And does it give the farmers so like sovereignty? And so the team started to think about that, building a machine learning model to be able to detect if a seed is GMO. But then we started to look into that project and realized that's really difficult to really know that from the plant. So we took a step back to redefine the goals and to see, okay, maybe to look at opinions about how people feel about this from different social media. So this was like this the second proposal that from the team to now take a step back to collect and gather information. So this was about that project. Then we had another project on building a rich fitness data set and recommender system. In order to be able to support people who are looking to get fitter. We have like another project on how to predict solar energy efficiencies of the buildings in Lagos, state Nigeria. And then there was a project on how to detect spam emails using natural language processing. A proposal also was made on how to predict or estimate the flood area. It started as Northern Nigerian, but the team also updates the scope of the project, which I think they would be presenting today, but we'll see that in the next slide. And then we also have the how to predict cholera risk in Kenya and Nigeria as a proposal, nutritional value estimation from Nigerian food, also another proposal. So also like there was a proposal on like customer segmentation using RFM and unsupervised learning. And lastly, we had a proposal on how to predictive maintenance model in Nigeria industry setting. Building a predictive maintenance model rather. So we would hear from some of this projects today, but I wanted to spend time to mention them because even though not all the team were able to finish their projects and present their work, they really did put in a lot of work to thinking about the problem, coming up with a proposal, and make significant progress. So we really shout out to them. We are very, very proud of all of the work that you've put in. I know a lot of these projects because we've also spent time every week meeting with the project team and discussing and providing feedback. So kudos, and I would like you to give everyone a virtual round of applause. Okay. So, but for today, really, we would be having 5 project teams present their work. And without further ado, we'll start, we would starts with the teams that are on call right now. The Truly Fit team, um, whose project is on building a rich fitness data set and recommender system using machine learning. Do we have anyone from the team? Can you just write on the call to say hello, hi, so we can know, or we need to proceed to the next team? Do we have anyone from building a rich fitness data set and recommendation system using machine learning?
Hi, teacher.
Oh, Abiola, I see you. Okay, great. Will you be the one presenting?
Yes, I'll be the one presenting, but I'll be first. Okay.
You
I'll
would
be the
not like
present.
you would not like to go first, is that what I hear?
Yes.
Okay. Do we have any team who would like to go first? Maybe Team Wapa. Chitom, would you like to go first, your team?
No problem.
Okay, so first we would have predicting solar energy efficiency of buildings in Lagos. Chitom, I have just made you a co-host. I would ask that you start sharing your screen.
Okay. Can you see my screen?
Yes.
Yes. Okay. Okay. Good morning, everyone.
Good morning.
Okay. Yeah. So I firstly want to say a big thank you to Team AI Saturdays for this opportunity. Yeah, when I started, I was like a beginner, but towards the end, I got like a good hold of what AI and ML is about, and I'm really appreciative. So more importantly, thank you to Teju for the guide and Yomifi for always being the intermediary between the whole process. Yeah, so my project topic today is predicting solar energy efficiency levels of buildings in Lagos. So the reason why I chose this topic is because I was just thinking of what's um, a project topic that I can do differently or that maybe might tax my brain a bit. So that's why I stuck with this. Yeah, so what this is about for anyone that needs clarity is we're just trying to predict, like it says, predicting solar energy efficiency levels of buildings in Lagos. So by having buildings in Lagos, we want to know, like, classify them into like based on their solar energy efficiency level. So the problem statement with this normally is we all, like it says, the space, our space here is Lagos. So the core challenge that we have here is normally Lagos faces a severe energy supply demand gap. So most people that are in Nigeria, they often tend to migrate to Lagos because it's the urban parts of the country. And with this, there's always an increasing population. And what we've had has always been a constant need for like energy demand. And the energy supply with this increasing population has always been constant. We can attribute that to the state of the national grid. And that's why sometimes we have cases of blackouts and things like that. So the demand for electricity continues to rise rapidly due to urbanization and industrial growth, like I pointed out. The national grid remains unreliable, and most homes or businesses depend on diesel and petrol generators. which are costly and environmentally harmful. So what we discovered, like Lagos, yes, is vast, but it has underutilized rooftops areas with strong solar irradiance that could generate significant renewable energy. So the central question here today is, which buildings in Lagos are best suited for solar energy installation, and how efficiently can they generate electricity?
Employed, but we know they're about to make the price go up. So yeah.
I'm trying to ask a question. Okay, yeah, so the reason why manual estimation doesn't work normally is because the current solar feasibility assessments in Nigeria, they are manual and site specific, requiring physical inspections. Just trying to say that people, like normally when they do, the way it has been done before is they have to go to the site and just look at it, which is not really sustainable. Yeah. So this process normally is time consuming, is expensive, and is not scalable to a city with millions of buildings. Why this project is important? The project introduces a data-driven and scalable approach using ML to automatically predict building levels, solar efficiency. So the project's objectives today is we are trying to classify energy installations into energy categories. That's low, medium, and high. We are predicting energy efficiency using buildings and installation features, supports like I stated earlier, and also to finally deploy a practical ML model for real world application. So about this data set, the data set was when we got to it had over 200,000 plus rows. And these are some of the columns that were listed from the data set directly. So we had the estimated building height, the capacity density, energy potential per year. And our target feature today is the energy efficiency category. So which was feature engineered into the project. That's classification metrics to classify the energy potential per year into like low, medium, and high. So this is just a screenshot of the data set. And the primary data set is like is a static building level rooftop solar potential survey. It was originally released in 2020, but it has been updated like twice, I think 2022 and 2024, but it's not like a year on year updates normally. So it's not a real time something. Yeah. So what we did was when we got the data set, data cleaning and pre-processing, we tried to feature some other columns that we felt might be necessary for this project. So in our data set, we had a situation whereby we had surface area of maybe a building, but also there's something called like peak installation area. So from what it entails, the peak installation area is just what part of that rooftop can we like the area that is needed for this solar installation. So when we look at it, like we think about it vaguely, you can say that that particular peak, something like a peak installation area is going to be needed more than compared to surface area. Surface area is just like the surface area of the rooftop itself. So what we did was after trying to feature engineer some columns, we removed invalid entries. We handled missing values. We dropped rows with nulls. We set the index, and we also tried to get more insights on the data by doing EDA. We checked the feature distribution, computed summary statistics, correlation heat map, identified strongly and weakly correlated features, detected extreme or outlier values. So while doing the EDA, for our correlation heat map, we found out that there was a distinct gap between how strongly and how weakly correlated features were. So there was more like it was a case of there was no middle ground. So we had for features that were kind of highly correlated, they were there, and weakly correlated, they were also there, but we just had few features that had that middle ground of like maybe 0.4, 0.5, something like that. So we also tried to address the issue of multicollinearity in the data and try to remove the columns that we felt might not be needed, and we kept the alternatives there. So when we did this process, we used our baseline model, which is the logistic regression. As I say, a simple linear classifier used to estimate the probability of class membership serves as a baseline to compare performance against more complex models. So what we got was an accuracy of 72%. And as you can see on the screen, this is the class-wise performance. So this is for the high, for the low and the medium, the precision, the recall, and the F1 scores. So from what we can take from here, we see that the evaluation metrics like captured for the high and for the low than you compare to the medium. Maybe because when we're doing the featuring, obviously, because the energy category column was something that was featured engineered. So you can't boil this down to maybe an overlap of because we try to put a threshold cut on trying to classify the data set. So what we used to even feature engineer that energy category column was the energy potential per year. Sorry. So next slide. So the model comparison performance improvement, we compared multiple by trying to, after getting that accuracy of 0.72, we tried to do more modeling because that's like the logistic is a linear classifier. So we tried to capture maybe non-linear patterns in the data set, trying to use something that has more robust structure. So we used random forest, and we also tried to compare it with other models. So we did decision tree, we did gradient boosting. As you can see on the screen, that's a pictorial view of what played out. So you can see the random forest had the highest mean CV accuracy compared to the gradient boosting, the logistic, and the decision tree. Yeah, so the chosen model for this was we just stuck with the random forest, and as we said, it was selected for the best performance in the model comparison. And it also robust to overfitting, capturing nonlinear relationships effectively. Then for the hyperparameter tuning, we tried to perform, it was performed using randomized search CV on the sample data, and this was the best parameters it found. So the reason we did this was, and another advantage of this random forest is it also tries to help prevent or minimize the issue of overfitting. So by trying to streamline our parameters with our model with these parameters, it serves that purpose. And this was the best parameter it found. So the final model, yeah, the random forest was then trained on the full data set. Then the final test accuracy was 78.89%. The key insights captures non-linear relationships effectively, handles strong and weak feature correlation better than regression or simpler models. The baseline logistic regression struggled with medium efficiency category that, like I earlier pointed, random forest improved the predictions across all classes. So the outcome model is ready for redeployment and real-world application. So if you click on that text option, it just takes you, is the link to the deployment interface where you can try to run your predictions on. So down part is just, the last sentence is just restating all that we've said earlier. So the real-world impact here is provides a data-driven method to classify energy installations by efficiency, supports policy making and energy planning for sustainable infrastructure, helps identify high potential areas for energy optimization, enables resource allocation based on predictive energy categories, and can be, can be integrated into part of my screen. Sure. Sorry, my screen is, I'm trying to drag some. Can be integrated into smart building systems or energy monitoring platforms, and the local impacts helps Lagos and Nigeria optimize energy infrastructure by identifying high efficiency installations, supports sustainable urban planning and informed decision making for national energy policies. So this project bridges data science and energy management, offering actionable insight for sustainable energy deployment. So this was the references and the acknowledgements. I want to say big thank you to AI Saturdays Lagos for giving us this opportunity. Thank you.
Thank you so much, Chitam and the team for your nice work. So, judges on the call, would you like to ask the team some questions or give feedback? You can go as you wish.
I can ask some question, but can everyone hear me now?
Yes.
Okay, good to know. So I was wondering, how could we generalize this to a different location? Let's say we want to also do this in Cape Town in South Africa, but we don't have any training data for the city. How would you approach this? Is it possible? What issues do you might anticipate? What would you pay attention to? This is kind of, yeah.
Sorry, I didn't get I didn't get the question. Can you just repeat your question, please?
Yeah, let's say we want to do this in a different city. For example, let's say Cape Town in South Africa. But we don't have any training data for this. How would you approach this? What issues would you anticipate? What would have one to think about and consider when trying to take the model, train it on one location, and take it to a different location?
Okay, so yeah, I get your question. So the thing is, every location has every, like Lagos now, it has different building like attributes and things that help to add up to this like information, like the way the data set itself was structured. You get, so I'm also getting in that sense that other cities also have things like that. Obviously, there might be similar features in both cases, like maybe in Lagos and in maybe the Cape Town, that South Africa they are talking about. So there might be similar things, but the thing is, and the way our model, when our model is like after deployment is, all I can say is um, this works for Lagos because it's different. There are things that shape it, like when you're talking about buildings, and also the reason for doing an installation on a rooftop here can also can differ from another city. So everything is bounded by its own location. I
Chitam,
don't.
Chiton, would you like to walk us through a demo, like a very quick demo of the project?
Sorry to ask, Teju, when you mean walk you through a demo of the project, do you mean the how it was deployed or?
No, I thought Precious just put on the chat the link. Isn't that your project?
I
Uh,
didn't. I've not even seen the chat box. Let me open it. I didn't see the chat box.
okay. I thought maybe that works and you would like to show us, give us a demo of your deployed model.
Okay, so I wasn't the person that I thank God is Precious that actually put that up because he's in my team and he was the one that helped to deploy the project. So I think it would be better if he's the best person that can go through
This
it.
is great. Okay, amazing. I just wanted your team to have the opportunity to demo this live as well. So, Pressure, would you like to do that? If not, it's okay. We are all already like over time. But nice work and
But Teju, if he's not responsive now, I'm trying to even understand exactly. Like you want me to open up the link and just show you how it works.
yes, that would be.
Okay,
For
let's.
example, Yosha was asking you, how would you deploy this? How would it change in the like if you went to another city?
Yeah,
Uh,
so
you
yeah,
could
so I
just
was even trying to answer because I don't know whether that reply was enough, but I just wanted to let him know that it's only if every city or state um city location it has what is bounded by like based on building structure, even the way our data set was like gotten that kind of thing. For example, if you can see my screen, you'd see that something like estimated till building heights here, all these things are what that needs to be available. So if you have these particular things in that your location available, you can maybe, but this particular data set is we just try to streamline our study to just Lagos, if that makes sense.
It
So
does.
here,
For your answer.
you said?
It does make sense. Thank you for your answer.
Okay. So
okay.
here is just by if can everyone see my screen? Still see
Yes,
my
please.
okay, so it's just you can input something 50 estimated tilt 50 degrees, building height, let's say 200 meters, capacity factor, let's say 12.5. I didn't plan to do this because I wasn't even the person that did the deployment, but let's play around with it.
It's a teamwork. Good.
Yeah, so the assumed let's do multi-family residential because we had the reason for this is for all those options is these were the available options from the data set itself. So multi-family residential. So let's submit and see. So predicted energy category high.
Oh, and the lot of
So
deployment
yeah,
worked for your team. It did not fail. So well
yeah.
done.
So by trying to like you can try and switch things, play around it. Anybody can try this. You can just play around it and you get different prediction level categories.
Okay. Well, thank you so much for your time and for your effort and great job to team Unwakba. And I would encourage you how to play around with this, and also the team has written a proposal, a project report to support their work. And so after the call, we will also send out the report, and you can follow up with the team. We are very much over time, but I'll try to keep the next few presentations on time. Please know that you have 10 minutes to present your work, and you would have 5 minutes for question and answering. And if we cannot take any question on the during the presentation, please put your question in the chat so that we can maintain the time allocated for each team. So next we would have team Truly Fit to present their work. Are you ready? Abiola, can you hear me? Abiola. While Abiola is trying to figure out his mic, I would like to call upon the team Nadine Godima to present their work. The presentation will be done by Damilola. Damilola, would you like to share your screen? In case anyone is talking, you are on mute. Okay, just give it a second. Do we have anyone from Ali on the call or Interlight? We can also go in any order. Okay. Onome, you're from Team Godemar. Would you be the one presenting for your team? Cannot see them Lola on the call anymore. Can everyone hear me though?
Yes, we can. We can hear you.
Okay, great. Onome, can you hear me? Do we have anyone from Team Godimar or Truly Fit or Interlight or Ali?
Yes, yes, we do. I'm trying to confirm who would present for us if he's ready. So just give me a few minutes. But in anyways, if there's anyone, any
I can't hear you anymore. Femi, are you the one presenting for your team? I know you're from Truly Fit.
No, it's Abiola. Although I don't know, he said he's doing something, like it's kind of probably in the restroom. So I don't know. Uh maybe just I don't know if I can just start. Probably
Okay.
I don't know if
Yeah,
it's
let's do that. Let's have you start and Abiola can continue when he is here. Or if you prefer, we can also take a short break, if it's like 5 minutes break.
all right. I think I'll prefer the short break. Okay.
Okay.
Take a break,
Okay.
yeah.
All right. So just to double check, we don't have any team ready to present right now, do we? Godimar, Onome, Damilola just joined again. Let's give it a second. Onamek, are you trying to say something? Okay, Abiola is back. Great. So Abiola, can you please share your screen and start your presentation? Abiola, can you please speak and share your presentation?
Okay, I told you, so I'm trying to share my screen. Sorry. Can you hear
Yes,
me?
I can hear you.
Yeah, I apologize for the delay earlier.
No worries. Thank you for coming back to us.
Okay, so where is this share button? Sorry, I'm not used to Microsoft Teams. Sorry, Google Meet.
Mm.
Trying to okay, share screen. Okay, please confirm when you can see it.
It's coming up.
Okay, okay. So my name is Abiola Wani. And with me on this call is Femi. So Femi and Cecilia are supposed to be here as well. Oh, I guess she's busy. One of our team members to see me. She was quite preoccupied, so she couldn't join us. So myself and Femi were here. So that's the member of Truly Fit project. So please, can you see my screen now? For
Yes, we can.
okay, thank you. So the motivation for this project was born out of curiosity to see, how we can have AI, help us, recommend meal plan and exercise. So of course we have seen some big tech gym company use maybe Google Fit and the likes, they use AI to, but coming down to my level, how can we build something simple, so simple that is also useful, that I could recommend, maybe exercises and maybe meal to meet an individual goals. Okay, so that's like the problem scope, the project scope, really. That's the motivation for this as well too. So how do we apply AI, into the world of fitness and nutrition? So we try to tackle it in a very, very simple manner, and based on our skill level, based on what we know, I say too. So that's that. So like I said, so I think I've mentioned this. So the key thing with this, we have, user with different profiles. Oftentimes, when you go online, you just have, people just tell you, maybe you read the blog, do this, do that, and most times it's not always tailored to your profile, your
Sorry,
weight.
can you please like make it in presenter mode by clicking
Okay,
on the slide?
slideshow. Sorry, okay, is it better now? Is it better now?
Yeah, much better. Thank you.
Sorry. Okay, just give me a minute. Okay, so like I was saying, I was saying that, when you go online, when you just Google online, per se, you just see, different exercise, do this, do that, and oftentimes they are not personalized, they are not tailored to, each particular user profiles. So what if you have a system whereby it takes in maybe your age, takes in maybe your weight, your BMI scores, your goal. Do you want to lose weight? Do you want to maintain your weight? Do you want to gain more weight? Then of course your activity level, how mobile are you? Then can we have a machine learning, predict, help us, guide us in terms of, the main recommendation and exercise that we can do. So now, for us to have such system to thrive, there's what we call TDEE. It's a TDE. So TDE refers to the amount of the energy intake that you need, that an individual needs, that you need daily to survive. So that's what it is. So it's calculated manually. So, but based on the data we have, so we're looking at, okay, fine. Since we don't have that as a target, so can we have, can we build a model that can, maybe simulate that, they can predict the calories that an individual needs. Then, based on those calories, then we can now, recommend the meal plan. Okay, so now for you to stay fit, so you have to, of course, for you to stay fit, healthy, you have to ensure that the calorie you are taking, you actually burn it. That has to be equal. The calorie intake should be equal to the calorie that you are burning. For you to lose weight, you have to be on calorie deficit. That means the calorie intake has to be lower. You have to burn, more than what you are taking in. So that's the whole idea of staying fit, gaining weight, and also losing weight. That's just the magic there, the calories. Okay, so that's it. So what we do? So we went to cargo. So cargo is our source. So we swap around and we're able to see a particular data set. Let me just focus through it. Okay. We can think about this. So we went on Google. So we saw a data set. The data set has 54 columns, and over 20,000 rows. And that data set it captures a lot of features that they look okay, but from our EDA, we're able to see that a lot of these features they are quite irrelevant to what we are trying to predict. We did feature selection, and we're able to see that out of these features, what we need to predict the calories are just core features, the core features which are the fat percentage, which are the person's protein percentage, the person's age. So just like four features, stand out. So we did. Mm, So can you still hear me? Can you hear me?
Yes, you're audible. Yes.
Okay, so we did our EDA, and we were able to see that out of these, just four particular features, they will be useful for our model. So uh, So based on those formulas, so we're able to build a model. So the model predicts the calories. Then, having predicted the calories, then we have from that same data set, we're able to filter out the meal plans recommendations. So that's using logic. So we're able to now see the meal. So the model uses those features, predict the calories. Based on the calories, they now give us, it now generates a meal plans. That one can follow. That is in to show that you are maybe you are healthy or obese. So now that's where we had basically. So we were not able to get to the exercise recommendation. So I just love to maybe just do a quick demo so that I'll just stop and just take from there of what the method does. Next slide. Just a minute. Okay. So I'm trying to share my screen, so I'll just go through the demo quickly. Is it visible, please? Okay, so now we haven't deployed it yet. So we plan on using Streamlit to deploy it. So we deployed earlier, and we had some issue with the code base.
So
So
what are you sharing? Because I think I'm seeing this. Okay, now I say your project report.
yeah, that's what I want to share. I want to share detail. Just give me a minute. I want to share it. I want to share them. Just bear with me a bit. Like it's coming up. Let's see.
Okay. So just to avoid this delay, can we make sure that the next team, they are prepared with their slides and their demo on the same tab if they are planning to give a demo, just to make us more efficient?
Always. Is it doing this? Sorry, I don't know why it's. Okay, okay. She's loading. So can you see my screen now?
Yes, we can see your screen.
Yeah, so I'm just trying to find my way around these things. It's hiding my tab. Okay, uh, so we have a template to just take in the user input. Like I said, so it takes the weight, it takes the age, it takes the goal. So the goal is divided into three categories. You want to lose weight, you want to maintain your weight, you want to gain weight. Then the height, the gender, then of course your activity levels. So we click on generate. So it's going to, of course, behind the scene. So all these features are not what the model. Of course, the model using it, but it engineers the core features. Like I said, it needs the fat percentage, it needs the protein packaging, it needs the lean mass. So those engineered features are what the model sees. They now outputs the calorie predicted. So yeah, we have so based off this user profile. So we have one thousand nine fifty. So that means the person daily intake for this particular person based on his profile, he needs these amounts of calorie. He needs to take some calorie, for the person to for the person to lose weight. For the person to lose weight, that means if I lose weight, that means I must not go above this calorie intake. Either I'm lesser than this, but I must not go way higher than this. Some will not be okay. What are the meal plans I can eat that will, that everything will communicate into me, reaching this particular, target and daily calorie. So it makes some recommendation like maybe smoothies, and tells us the calorie breakdown, the protein, carbs, and fat percentage, and the categories. Okay, this one go for breakfast. This one going to go for lunch. Go for dinner and snacks. So just give this. So the idea is supposed to be, the model gets to recommend this, daily. So the user is supposed to. So if I'm losing weight, for example, I'm not supposed to to go above this particular value. So now, so it matches. Then just give me the breakdown of. Though yes, so give me the breakdown. So now the next phase of this will now be which we are not able to add to this because of some couple of issues, which is the exercise. So it's supposed to recommend the exercise, but we are not done with that particular areas. Yeah, so that's another place of improvement. So on side of improvement of things. So now looking at the recommended meal plan. So we thought of maybe adding like a portion, maybe like rations, so maybe we can ration it, maybe 1.5 portion, 2.5 portion. So I know I must not go past this particular value. So I can ration it, maybe I should eat maybe half portion. So maybe in another tab, I can help, ration this the recommended meal. Then another further improvement will now be also so now this is just the first user so as user keep using these predictions, so we expect to log feedback, so how are you losing weight, so as it's logging those feedback, so we can also use that in a way to also to train the model so that the model can be much more personalized for the user experience. So it has like a cycle of tracking. So are you able to follow the meal plan? Is there any signs after 1 week, after 2 weeks? So there should be room for you to keep track. So that's how the model is going to learn as well too. Then also, so one of the of course we have all this in our head, but like I said again, coming to our skill set again. And that what we also thought about is trying to maybe integrate an LLM just make, after you recommend the meal, just give like a personalized message, add your name, something tailored to you that will look so, not just, do this, look so maybe personal in terms of conversational style, and as well too. So, so that's it from my end. Thank you for this privilege.
Oh my goodness, like I'm already hungry right now. Well done. Oh my God, this is really, really cool work and love it and love the demo and love the plan. And so well done, really, to you and your team. And I really hope that you don't stop now. You follow this project to the end because I cannot wait to try it out. I'm not joking. Like I want to try out this meal plan and log it and then give feedback and see if it's helping me because this looks like healthy meal plan. Like I always don't know what to eat in the morning or in the afternoon. So I would I would appreciate some recommendation for food and then just try it out and see if I want to lose weight or like another extent to it might be that okay, I started getting into running and I want to know how to properly fuel myself so that I don't like I have the best workout and also like maintain whatever like body I am trying to maintain. But so it's really nice. It's like possibilities like infinite. So well done, and thank you for walking us through your project. I'll give the room to your judge to maybe give some feedback or ask questions.
Yeah.
Mm.
Hi, Abiola. Well done. I think this is a very cool project. It looks like a passion project, something like that somebody who is really interested in fitness would want to do and use. So I think it's a very cool project. Well done. Also, I checked your repo, and well done was like what you have there is really well documented. You explained your thought process clearly, showed the like it was well structured. That was very, very impressive. So yeah, well done on that also. And when I checked Git, I saw you have a system architecture, and that was really impressive. So do you mind walking me through your system architecture?
Okay. Okay. So now of course like you mentioned that is a is a passion project because I've been trying to myself. I think I was one that actually convinced in the group that let's look into this because I've been looking into fitness myself, trying to still fit myself. So when we were told to come up with a project idea, so I just went on Cargo. Initially I don't even know team, we are just brainstorming what can we do, what can we do. So I went on Cargo. So I just stumbled upon this data set, and I just thought, okay, let's just say I go. Initially, it was looking wired. We don't even know how to approach it, but okay, let me just take you through that quickly. Where did I drop into it? Okay, so now, so for this, so now, like like I said, so there's the user profile. That's like the interface we just seen. Whereby we have like a means to ingest data from the users. So of course, in this regards, we're just using like a web app interface, whereby user get to, click in real time. So after the user enter, that's the first line, that's the A part. After the user enter, imputes the profiles. So what the model does, so it predicts the calorie, and like I said, so what is being received, is not directly what the model is using. So behind the scene, there is at the back end there's a feature engineering going on, whereby we have some, of course, some feature engineers, some calculations whereby you get the lean mass, we get the fat percentage, we get the protein percentage just from, we get the BMI. BMI, of course, BMI from the weight, the ratio of the weight to the height. So that's what those are what the model receive. The lean mass. The model received it, and he was able to predict the calorie. So after that's the B part now. So after the calorie has been predicted, so like I said, the calorie is like the daily intake. That your body requires. So if you have a lot of calorie, obviously you're not burning that much. Of course, you're actually what you'll be gaining weight. You're having tummy. You're having fat storing everywhere you want to store. So that's what the calorie. So it gets the calorie target. So now based off this now, so based off the prediction. So we now use, of course, from that data set that we have a cargo, it has a meal, maybe those are like I think they commented about the meal. Then, but before this, so we tried to the enrichment part is we're trying to break it down into cabs. Then that's when we look at the particular site called USDA API international website whereby they can give a breakdown of food values. You can send the food values by API calls, and you can get the composition. But of course, that one we try using that first to make it make it more real. But we discover that you can just have maybe one call per day, which is one call, and before we know it, we can't get that quantity that we have. So we just went back with the data set as well too. So now the C to D part was so that one, this workout plan generator is so is what we are getting off. So we're supposed to have, it's not as if maybe we could not have added it, but we, because of time constraints too, it hasn't been easy for the team trying to work and everything together. So, and I know we started a bit slowly. We get into it, at some point we had to look as well. That's why we could not had, this workout plan. So I know after now, I've actually had the workout plan generator. So having that, then the E part will now, after I have the main plan generator, I click on generate me, I get that. I click on generate workout. It gives me the workout. Is it high intensive? Is it cardio? Am I doing cardio? Am I doing runnings? We don't have all this template down already. We just have to just work on and just have then I have my results. So when I spoke about the future improvement, the user now gets to now log that progress. Okay, are you taking the meal? What's the effect in the meal? Are you seeing changes? The exercises that you are doing, is there an improvement? So you log the progress. Are you able to stay true to the meal? Do you know every day? Are you able to maybe do that? Is the meal okay? So you can just, that's where the user progress logging comes in. Then making it more adaptive, whereby the model now learns, because now we just train the model over different user profiles, but to make it more personalized, that's to capture your your details, your information, your export, and that's going to make it more distinct to you. So this is like an high level overview of the system architecture, what it does. So also, I think I didn't mention this maybe because I was a bit tense. So the model that we use for, of course, we try some couple of model. So we try software vector machine, we try linear regression model, which are base model. We try random forest, we try the SG boost, we tried even the regularized regression, the ridge lasso, and the elastinate. So we try those. We try all those. I think I love this on my DAX of MFlow. So it's where track this calls. So and of with all these models, so the one that actually stood out that I performed the rest was the random forest. I don't know why random forest always come out top. So was random forest. So it has like a means absolute error of of 73. I know in our book we wrote 97, but after that we now did tuning, appropriate tuning, validation, so it reduced further. So that's why we have 73. But initially it was 92, so we tuned it a bit and we arrived at 73 accuracy. So that's the model that we use, random forest regression model.
Okay. So when I saw this, I just like, it made me know that it's like a well thought of idea. It was not just that you wanted to rush do something. You actually sat down and decided to, walk through a plan. Yeah, and that's very impressive. Well done. So I have a suggestion. Do you know of Base 44?
How?
Base 44. So it's an app that allows
Yeah.
you, like, turn like an idea into like a live demo. It gives you like an MVP, like work on. So I think that in your free time, you could, put your idea into Base 44. Just check it on Google, and it's going to give you like a kind of like a demo app. So I think from here, you might try to do that also and see if you can maybe add more feature to this and work on it in your free time, because this is like really interesting and very impressive. So yeah, so well done. My other question is, when I read your problem statement, I think you wrote something about trying to enrich the data.
Yes.
Okay, did you do that? Were you able to?
So so the thing is, so we were not able to, well, I won't say we were not able to. So initially, the initial data set that we saw two data sets, and of course they are different. There's
Okay.
one on gym. So on that gym, we just have the user. It's quite streamlined. We just have the gender. We have the gender. We have the BMI. Then we have the meal and the exercise schedule. That's what we have for that one.
Okay. Okay.
So now for the meal, they just tell you eat this. So there's no breakdown. There's no, that breakdown of maybe protein, carbs, the content is not there. So that's the first one that we saw. The second one also was just clearly about exercises. So now, of course, before we thought about merging those two together, but yet we won't have the breakdown, the macronutrients, the breakdown of those what that food can contain. So I need to know what I'm eating. I need to know I need to know the protein. If I want to, if I want to build muscle now, and I will need more of protein content in my food. So that's why, okay, so without thought of food, can we have in a way whereby we can now break that into macronutrients? That's where the enrichment now, comes in. They were trying to use the USDA, the website about food nutrients. Then, as we are surfing, we keep, disturbing cargo. We eventually stumble upon one lifestyle data set that this one is quite massive. That's 54 columns, so it has those macronutrients breakdown. So we now eventually now use that for the model.
Okay. Thank you for your presentation. It was a very good one. Well done. I look forward to what you guys do more on this project. And so in ASR today, we have a lot of people that are very good at what they do. So in case you want to continue this project, all you need to do is to reach out to Teju, to reach out to anybody who would be able to, offer you some advice in their free time. I think you do not understand the kind of professionals that we have here. So if you are willing to continue this project, just write out a plan, reach out to Teju on the kind of advice you need. She's going to plug you with the right person that would help you out with some of these things that you need to do. Yeah, thank you very much. I thoroughly enjoyed reading what you wrote. I thoroughly enjoyed listening to your presentation and to this demo. Yeah, best of luck in your weight loss goal. And yeah, thank you.
Okay, thanks a lot, Tola. I just one last thing I wanted to add, Abiola, of course, like all has been said. So when you said you've not done exercise generator, imagine I also said that that sometimes I know that I want to run, like I want to be better at running. I just want to know what kind of meal plan to add to it and everything. So if you let's say you generate calorie, like you have a calorie target, like maybe I also want to be leaner or something like that, and then the person is like you can I'm thinking of a flow where you can also accept inputs from the user as to what kind of exercise they are doing right now or they want to do. You know what I mean?
Yeah.
To kind of like be more like collaborate, but of course follow this plan that you have, but just thinking about other kind of use cases like from different users. But great
Yeah,
job.
yeah. So the thing is, well, we like I said, what actually is, make us slow down a bit was, we were thinking about endless possibility, things that we can actually do with the project. So that's why at some point we got confused actually, myself personally. So because the different way of going about this problem wasn't yesterday when I was even checking cargo. I saw I saw maybe I was going through and I saw someone that did something. And I was like, how did you do this? How did you do this? So at first we have different features we want to put in mind. So that actually bog us down much. I just say no. Let's start with something that is simple that we can for
Yeah,
now.
I completely agree with that. Start simple, and this is already good. Like once you have this and you deploy it fully, and I hope you do. I will be reaching out to you to make sure that you do, because I want to see this actually on like live on some app that I can install and then see how it's going. So let's make this happen, Abiola. Don't lose the momentum. It's a really good and interesting project. So keep it up. Great job to team Abiola, team Truly Fit, not just you on the team. I know, like I've met with your team every week, so I know that like Femi is also there. So well done to all of your teammates for this wonderful work that you've done. So next we would have Team Godima present. Please go ahead, Damilola, if you're set now. So interestingly, Team Godima is also about food, so exciting. Okay.
Yeah, please enable me to. Yeah, I want to present. Please enable.
Oh, you're the one presenting now. Okay. I've just made you a co-host.
Thank you. Okay, good morning, everybody. My name is Onome, and here with me on the call is Damilola as well, and we're
Onome,
talking about.
Onome,
Okay,
I'm so sorry to interrupt. Before you start, can you try to minimize the Zoom there, just to make sure we see your can you see this app.zoom.org surface?
yes,
Yeah, that one. Can you please hide it somewhere so that we can see your entire screen or
okay,
minimize it?
okay,
Maybe you can close it. Like, should be okay if you would. I think it should be okay. I'm not sure. Oh,
I'm not sure. Okay, maybe I'll just hide it somewhere.
yeah. That's good. That's great.
Awesome. Okay, so we're a team Nadine Gordima, and our topic is on nutritional value estimator for Nigerian food. So we all built had to do with estimating the nutritional value of the local foods we have in Nigeria. Okay, so the problem statement: so Nigeria faces a triple burden of malnutrition, undernutrition, and eating hunger, which is a micronutrient deficiencies, and the rising obesity. So food labeling is almost non-existent in Nigeria. So families, schools, and NGOs can't easily assess the nutritional value of common meals like the bread, like the rice. They are not really sure which is more nutritious, okay, to be taken. So we aim to build a model that can help any category of users to identify the nutritional value of a Nigerian food when a meal name is entered. So we're able to access data from the Nigerian food composition tables, and we also use that of ShellNet, and we also accessed another data set from Nigerian food, that's from Cargill as well. Okay, so we are such as Nutritionics and ShellNet to carry out this project. So the aim of this project is to develop a nutritional value estimator that identifies the macro and the micronutrients of Nigerian meals through a meal name lookup system. That means in this application, all they just need to do is to enter the name of the food, is it jollof rice, and immediately it's going to tell you um, the value, the nutritional value of that particular meal. If it's beans or any form of meal, once you enter it on the app, it should be able to tell you the value, the nutritional value of the meal. So our project methodology was into three. Number one was identifying the problem, which has to do with identifying and understanding the problem we are to achieve as regards this project. Then our next problem identification methodology had to do with analyzing from a public health and user perspective. Is this workable? Like, so we have to analyze it. Then focusing on the lack of accessible nutritional data for Nigerian meals. So during this project, we had a whole lot of challenge trying to get a suitable data to carry out this model project, to carry out this project. But we had a lot of options, but all the data sets we had access to, didn't have the complete features we needed to carry out this project. So that was the challenge we had. Then, as regards the data analysis section of the project methodology, after we were able to get the data we wanted, so what we did later on, we had to create like a new data set with the features we needed that had to do with the name of the Nigerian food, strictly Nigerian meals, like a foriro, beans, ogbono, all these day-to-day meals of a typical Nigerian. So we were able to create a new data set. We also had feature columns that had to do with the mineral composition of each of these meals, the vitamin composition, the potassium, the protein level, the fat level, and so on. So, and after doing that, we had to data clean. We had to also detect the outliers and created new features for the macronutrients as well. So some categories, like we created new features like the swallow category, the rice category, and so on, and the soup category. Then we also created new features for the region. So this particular meals maybe is made for South Nigeria, Southern Nigeria, or West Africa, and so we just created new features and nutrient riches as well. Then data exploration and visualization. So from this data, we're able to, which we'll be seeing later on, we're able to get some visualization as well. And down to the third methodology, which has to do with the machine learning section of the project. So we carried out data pre-processing, and we built the machine learning models. We used the lookup, linear regression, and the KNN was what we used. Then we also evaluated our model, and presently we are in the model improvement and deployment stage. Okay, so from what I said earlier on, so this was what we got when we tried using like this particular data set. We tried using the nutritionics data set, and it gave us the images of day-to-day Nigerian meals. Okay, but we also needed other features that we're lacking, in the data set. So we had to try another data set, and this particular data set, we got it from dish underscore ingredients. That's from one of the federal government sites where we get data set from. But it lacked the dish's name, so it was in code. So it was a bit of challenge seeing the time frame we had. So this led us to create our own data set, and this is what it looks like. So yeah, we had the food name column, okay, like the jollof rice, moi moi, eforiro, akara, the amala. Then we have the category, like the jollof rice in the rice dish category, the moi moi is in the steamed beans pudding category, eforiro is in vegetable soup category, akara is in the fried beans cake category, amala is in the swallow category. Then we have the feature for the region as well. Okay, so the jollof rice is like known in the whole of West Africa as a meal, and moi moi the same thing. Eforiro is basically being consumed in the southwest region of Nigeria. Then akara is also in this West Africa region, Amala is southwest as well. Then we also have their calories, the feature for their calories, the protein, the fats, the carbohydrates for each of these meals, the vitamin level, so that they can basically know that, okay, for instance, Eforiro has more vitamins. That's why it's healthier to be taken. And these are the minerals for each of these meals. Next slide. Okay, so the there were some outliers. So this like the data shape after removing the outliers. Okay, so we got some visualization as well, distribution of calories. This is just a few of the visualization we got from the data set. This has to do with the distribution of protein, okay, and that of calories as well. And we also talking about the data analysis aspect as well. Yeah, these are all other visualization from the data set we had. For instance, displays the first few rows of the data frame. This one is trying to, for each of the features, is trying to create like a visualization for each of the features. This is a 2D distributor, and the values, this like the faceted distribution for each of the features we worked on. Then we worked on the summary statistics as well, where we have the count and the calories, protein as features, fat, the carbohydrate on each of the features, and these are the summary statistic figures we got. Then the correlation matrix also gave us an output as well, and we also used the box plots to kind of determine to see the calorie distribution by food category. So that here we have the rice dish is for the rice dish, and we saw the calorie level. The steamed beans pudding, the calorie level is very low. It's like even non-existent. Vegetable soup has its own, but not like rice dish and so on. So these are some of the visualization we were able to get. So summary of our findings and our next steps. So we have successfully completed the data analysis and machine learning stages of the project. We created a simple data set of our Nigerian food with nutritional information the way we wanted it. Then we performed data cleaning. We handled the missing values. We removed the outliers. We engineered new features like the region and so on, including the macronutrient ratios. We also conducted the exploratory data analysis to understand the data distribution and relationship. We built a lookup-based model for direct retrieval of nutritional information. For instance, if you put in chicken, a chicken is going to tell you that is not part of the list. So we're able to look up some of these meals and know what is missing. That's the essence of the lookup based model that we built. So we built and evaluated a linear regression model and a KNN model for predicting nutritional values. And the KNN model showed better performance than the linear regression model on this data set. So our next step is to deploy it into an app to make it usable so that once they just put the name of the meal, it should be able to tell you to estimate the value, the nutritional value of that meal. So this is the next step, which is to prepare the final model for deployment. That's to create the model using Streamlit. Our co-host talked about base 4. I've not really used base 4 before, but we're looking at using Streamlit, and maybe we can touch on base 4 and see how it will look like. Then evaluation and testing, we intend tuning the app. We need intend testing and deploying the app with example queries and compare results with reference data sets. So I think that's all from my end for now.
Thank you, Nome. Can you please go to the previous slide? Thanks. So looking at this box plots, you said that like the steam bin pudding is almost non-existent.
Yes.
I just wanted to correct that. That's not, I don't think that's the interpretation of the box plot, right? It just shows here that it's not there's no high variance in that data. So because you have only mapped Akara to steam bean pudding. So like the question I would have is like how many like instances of steam bean pudding did you have, and did they vary with different like calories? So that's how like the box plot is showing you the like the variance, right? It's not showing you whether or not it exists, because if it does not exist, then the calorie should be like 0, right?
Yeah, that's true. Yeah. So
Okay.
it's minimal. Yeah.
Yeah, I mean, it's not like there's no variance at all. It's just like maybe the same value. Like for example, maybe you only had the soup category, maybe you only had one soup or something like that, and it only had one value. You didn't have like multiple different
No,
soup and
no.
have like different values. I imagine that the rice dish you had like jollof rice, fried rice, some other kind of rice, and they all come with different calorie values. And so this is why you can see this variant, and it has a median of around maybe 360, 380 or something like that. But this is what the box plot is telling you. Not that it exists or does not exist. If it does not exist, then it should be like calories of 0 or something like that. Yeah, just wanted to point that out real quick, just because maybe other people also on the call might have like questions around that. Um, yeah, I would give the room to your judge to ask questions. Judge, would you like to ask some questions?
Well, I have a couple of questions. By the way, awesome presentation. So I have a couple of questions. So the first one has to do with, I think you mentioned you used a couple of data sets, right? And I was really curious on how you combined the data sets. I know you mentioned the ChowNet, you mentioned one other data set from National, I can't recall. So I was really interested. How did you, like on a high level, how did you combine the data set? What was the thought process behind combining the data set, and what was missing, and what were you trying to like achieve?
Yeah, so the original plan for this model was to involve the image aspect of it so that with just a snapshot of a meal, then the app will be able to tell you the nutritional value. Okay.
Okay.
But because of the time frame, we and for that image, we would have loved to use ShellNet for that, but because of the delay in trying to embed the image generator, the AI image generator application to our data set, we had to cut off that section. So we didn't we want it to be a simple data set. So we had to just make it as simple as possible. So for ShellNet, we have the images of the meals, we have the multi-labels of the meal, that the food names, but we didn't have the nutritional any nutritional information for these meals specifically. So that was the challenge. Then we had these other data sets from the ministry that has a whole lot of the nutritional features, but the dishes were not labeled. So trying sorting this data and merging it was taking time. So that was why we just had to create our own data sets using a dictionary. I just created our own data set with the features we wanted. Okay, so we were subsequently we are looking at when we embed the image section of this model. We are looking at merging, just merging this data sets together. So that's what I wouldn't know if I've been able to answer your question.
Okay. Somehow I think you're able to answer the question. Okay. My second question has to do with the most common meals, the most common and the least common. You like, what were your observation?
Okay.
You don't have to show me. Like, if you can just recall, you can just tell me.
Okay. So the question is what my most common
Like the most common meal or the least common. Like, what were your general observation, like in terms of when you were doing your EDA?
Okay, yeah. So I noticed that most of the most common meals that we pick are mostly carbohydrate based from the exploration from the EDA we carried out. So they were really like bread, rice, basically rice to get. So most
Yeah.
of the major consumption of our meals are in fact calorie based. They are carbohydrate, mostly they are not really nutrition. They are low nutritional value, and maybe that's why we've had these effect of obesity and malnutrition, all this while. So that's what I was able to observe.
Okay, I think it's similar to what we noticed with Charnet. Then another question is, when you did your feature engineering, you did mention you did feature engineering. So what was the impact of your feature engineering? Like, did did it improve your model performance, or like what was the impact of feature engineering by introducing those regions and other things? Like, how did they influence your model performance?
Yeah, it was able to influence the model performance, but um, the difference was not really too much. It was not really large per se. But one thing, it's able to help us locate like the region where this like for instance a folio. Okay, so it allows us to say this kind of meal is particular found in this particular region. Okay, so that was just, and then they also created like a macronutrient feature as well. So it improved the our model slightly, not like it was not really pronounced.
Okay. Then one last question is like, it's an open-ended question. Let's assume that you have all the resource in the world, right? And you want to like embark on this project. How are you going to do it? Like, let's just assume that, oh, everything you have the right team, you have the right resource
Jesus.
to approach it.
Sorry, I'm
It's
on
fine. It's
the.
fine. It's fine.
Okay. Yeah.
Can I
So
go
if
ahead?
is that okay? So is that Damilola? Sorry.
Yeah,
You
yeah,
can continue,
I was
please.
gonna
Okay.
respond. Yeah, you
Okay.
can go ahead
Damilola.
and rant, please.
Okay. So Damilola, would you like to respond to this question, sir?
All right, that's great. So pretty much, if we have all the resources, that's I mean, first of all, I just want to say big well done to Onome. She has been very helpful on the project. So if we have all the resources, I would think this in three steps, right? And I would say that if we could build a recommender system that can actually give feedback on nutrient value just by snap, that would be beautiful, right? And yeah, it's novel, but it's possible.
Okay. All right. I think like with respect to that question, I was thinking about what we've done already and how will I even go about this? So we already have data sets with images, and I think I had a conversation with Teja about using a VLM with this. And the question will probably be more or less like, let's assume we have like a visual language model that can take these images and map them to the food content. Then from the food content, we map the nutritional value, right? So that was like a very super duper low hanging fruit, thinking about the lookup table you guys actually do already have. So
So we
this is
actually
like a
were even
project.
thinking of. Okay, sorry. So there was a time I think there was a suggestion of even using RoboFlow to, try to document food image data set, but it was a long haul. And yeah, I feel that I also saw the idea of the VLA when I was reaching out with RoboFlow and seeing how, if one wants to actually, someone is raising their hand, so I don't know if there was a question at all. But anyways, I don't know. I'm also, it's possible. I've seen videos that even from your phone scan, you can. I've seen a video like that for flowers, right? So I think it's still possible for food, but yeah, it's going to be a lot of work. A lot of work in the sense that um, jollof rice or in itself, the way it's been made by different persons it differs, and you want to also identify, nutrient value. That's a lot of work, right? But definitely,
I,
I was also trying.
I, I don't want to say
Go
it does not involve a lot of work. I'm just saying like so most times what you want to do is you want to have like something simple, right? There's nothing wrong with
Okay.
thinking about the work. So like, okay, if I'm going to use a simple way, like a simple way around it is for now, given that the technology had becoming better. Like few years ago, we didn't have good object detection model. Now we have good object detection model. Now we have something better than good object detection model. We have something that can understand the images, understand like context within an image, right? So now you have a VLN. Oh, this is Eforiro, this is this. Awesome. What is the nutritional value of Eforiro? What's the nutritional value of rice? You understand what I'm saying? Like it's a things are getting better. It is possible, right? But in general, I like the whole idea of, or I like the fact that you guys decided to like decouple the hard thing and focus on the simple thing, not necessarily the simple thing, the low hanging thing, right? So that was the reason why I asked, okay, let's assume you have all the resources in the world. How are you going to go around it? And this is like a something that you can actually try. And I think you should try it because that visual part of it is actually very important, right? So maintaining or still incorporating that visual components gives the project a lot of context or a lot of value to deliver. So the idea of just typing in rice and getting the nutritional value sounds cool, but if I can take image of rice with some other thing, okay, I'm seeing rice here, I'm seeing beans here, I'm mapping it to the nutritional value. It's kind of cooler, you understand? So yeah, I think that's all I have for now. Awesome work, and Yeah. If you're thinking about possible areas of extension, that's like something you can actually do. Yeah.
Thank you so much, George. Are we gonna take the last question from Tola? Yeah.
Yeah. So what I want to say is that there are big problems and there are small problems. I think that if the first problem you tackle is creating the very robust data set, that's impressive already. So I think I like the idea that you guys thought about a problem and created data set yourself. So if you could make it more robust and make it that publicly available, even if you don't work on the continuation of this project later, it's going to be a good starting point for somebody else to pick it up in the future. Or even if you decide to pick it up in the future, yeah, that's something in the right direction. So I think that while there are like bigger things that you could do, you could also start from doing these small ones very, very well. Then in the future, you do the big ones also. Yeah.
All right, thank you very much. That was actually very insightful. And yeah, we gathered 800 image, and I think we can actually take a step forward by making it open. Anyone can use it. I mean, if we go ahead with to making 5,000 images, that's also great.
Thank you so much, Team Godima. Nice work, and I look forward to seeing like those improvements. I know that we now have concluded the first phase of the project, but this is not the end. It's just the same advice to the previous teams. Continue working on it, and that would be like phase two, phase three. You never can tell. So we have two more projects to a presentation to go through today. I hope you stick with us until the very end. These are really interesting projects, and I did not want to interrupt the discussion because this is even more important, like to be able to like talk about the problem the teams were trying to tackle and get feedback from experts on the call that we have. So the next team that we have would be Team Internet. Could you please go ahead to share your screen? And a big round of applause again for Team Godiman. Thank you. Onome, could you please stop sharing your screen so that Team Internet can take over?
Can you hear me?
Yes, you're audible, Ahmad.
Oh, okay, sorry. Can you hear me? Okay,
Yes.
it's Peter. It's Peter. Okay.
Oh, it's
It's
Peter. Okay.
yeah. I apologies. We are trying to make it work as a team because mm, he so Kamal will be presenting while I'll be speaking, right, on the
Okay.
project. So I'll be very brief. So split the task into two. I'll do the presenting, then Amal will do the action of the questions. All right. All right. Basically, the project is simply to incorporate maintenance into smart manufacturing, actually. So with the advent of industrial IoT 4, that's industrial technology 4, we are actually looking at um, firms moving away from maintaining machines manually and through schedules um, into using predictive system basically for such things actually. So the idea basically move on to the next slide, please. Ahmad. Ahmad, next slide. All right. So basically the project was just centered on moving away from um as I said earlier, into plant maintenance into predictive maintenance. So the content basically was strictly based on the abstract problem statement, the aim, the project methodology, data collection, processing, method, selection and training, and evaluation as well. So next slide. Well, as I said earlier, the study actually was meant to just apply machine learning to predict equipment failures using different factors. So basically, we sourced for data from cargo on predictive maintenance. So what the data was all about was um, a system that has different sensors basically that identify different metrics for machines, temperature, vibration, pressure, and the rest. But the issue we had with the data set was that all of those parameters were not stated explicitly in the data. So you just have metrics 1 to 4 being stated in the data. So that was the issue we had. So we had to do a lot of and feature engineering to see if we could come up with something at the end of the project. So next slide. All right. So the problem system basically was is basically despite the availability of extensive sensor and operational data, we have industries that still depend on reactive maintenance and so reactive maintenance basically speaks to machines that are fixed when they break down. So instead of you having a planned maintenance schedule, you only fix your machines when it fails, and that's what we're trying to prevent by using a system that can predict that a machine would fail in the near future. So as I said earlier, the data set was sourced from cargo, right? And the aim basically is to forecast equipment failures, and for it to also come up with proactive measures to resolve those maintenance issues when they eventually happen. So, quick background story. Yeah, I work in manufacturing firm and also in the maintenance and reliability department. So, over time, we see that planned maintenance schedules most times might not work because machines have maybe during inspections and things have been there's been some oversight basically, and those data eventually culminate into breakdowns happening intermittently in between schedules for maintenance, right? So that would actually, with this system, deploy machine learning here would help us to spot all of those issues in the machines as identified by the sensors and different indicators that machine might have. So it might be temperatures, pressures, vibration, and the rest, right? And we can use that to predict if a machine would fail in the near future. So move on, next slide. All right, so basically, this was the project methodology adopted. We had model selection and training, data collection and preparation, deployment and monitoring, and also model evaluation after all of the cleaning and feature engineering have been done. Next slide, please. All right. The issue we had with the data, basically, we noticed that a large portion of the data basically actually speaks to machines that had no failures at all. So you can see we had about almost 124,000 rows that are more than more which speaks to machines that have not failed over time, and we only have 106 of them that have failed over time. So that give us a problem with overfitting. Eventually, when we were doing our implementation, but however, we did some data collection, some feature engineering as well. So what we tried to do was to first of all, these are the metrics that came up with the data. Next slide. Then we did analysis and also did some feature engineering. We tried to come up with rules like average failure rate, static method failure rate, max failure rate to just add some meat to the data to see if we could come up with anything that could solve our fitting problem. So, however, move on to the next slide. After all of the feature engineering, this was the most relevant graphs we were able to come up with. The risk of failure, we noticed that machines that had 0.0. So what it means is that if your machine has a value of 0.08, that means it's not likely to fail, or it's not going to fail at all. If it has 0.1, it means that's probability of 1%, or sorry, 0.1 probability of failure, 0.2 of failure. So that's what this graph speaks to. So the risk of failure of each device. So you can see that from the data, we have about over 1,000 devices that have a probability of failure or risk of failure of 0. So that gave us a big problem. However, we proceeded with the data and still analyzed to see the top 20 data devices that cost us that had the most failures basically. And we saw that the first one, which is SIFORRB1, was culprit basically when it comes to devices with failures. Next slide. All right, this just shows the non-failure data and also the failure data as per date distribution. So we also analyzed the date to see which of the data had the highest failures and those that had the lowest. So from our data, we noticed that major failures actually happened in January 2015 and in June actually, right? So that's where we no May actually. So that's where we had the most failures and non-failures. We noticed that it was a downtrend basically. So the trend of failures reduced from January drastically downwards. Next slide. All right, so some of the discoveries we found with data is first of all, data was a clean data. We had no missing values basically, but we had a number of large portion of the data spoke to devices that had no failures at all. So we had about over 120,000 data rows that had zero. That means they had not failed at all. But for the other ones, we had just 106 that failures, and that's about 0.1% of the overall data. So non-failures contributed about 99.9% and failure 0.1%. As I said earlier, for devices that failed, we had S1 FORRB1 as the top one device with failures, basically. The next slide. Next slide, please. All right. So due to the issue we had with overfitting, I said earlier, how we spotted this overfitting was we combined a number of possible machine learning models that could work for the project, from linear LDAs to LRs, and combined them to see which one gave us the highest accuracy, right? And we noticed that a lot of them were already at the 99% accuracy. Why? Because of a large portion of data we spoke to non-failures, basically. And that gave us a very big problem. So what we were trying to do all through the notebook was trying to reduce or solve the overfitting problem. Next slide. All right. Accuracy was a major metric we used to evaluate all of these models. And for us to solve the overfitting issue, we had to do a lot of hyperparameter tuning, basically. So after hyperparameter tuning, a lot of these models still had this same accuracy. So it did not really do so much to reduce, although it reduced the overfitting, the accuracy slightly, but it was not so significant. And so we had to look at other methods like PCA. PCA actually speaks to principal component analysis, where we combined all of the X features, I mean, all of the matrices from 1 to 9, as well as the other ones that were added through feature engineering to come up with the most relevant components that could have contribute the highest to the failures and non-failures. I mean, the target variable actually. So and then we were able to reduce the data or the X features or the X features, the features from about 28 to about 11 principal components, and those were the most relevant ones that affected the outcome of our data. So after PCA is some form of unsupervised learning that was done to the data. So with that, to be able to reduce, next slide, we're able to see some improvement in, unfortunately, these results are quite small, but we're able to see some significant reduction. And we noticed that MLP classifier, next slide, please. Next slide, Kamal. Okay, MLP classifier actually jumped, please move back a little. One slide back, please. One slide back. One slide ahead. The next slide. Yes. So MLP classifier that was fourth on the list of models performed better this time after PC analysis. So we were able to reduce it from uh, a higher. First off, we were able to reduce it from a higher model accuracy to a lower one. Then we're also able to stimulate or steady the values for the accuracy here, and we had 99.94% for MLP classifier. So the three models are actually stood out as the most suitable models for this sort of data. Um, Next slide. slide. Come on, next slide.
Hello? Hello, hello?
I think we can hear you again. Or maybe not.
I think we lost you, Peter. Your volume is quite low now, or it was low earlier. Hello? Okay. Ahmad, do you want to finish up for Peter?
Okay, hello. Okay, so basically we would recommend that Nigerian industries use mostly exposed or lightweight GBM, and basically detect anomaly using tools for better predictions of failures. Also, we could actually get larger data so that we can better predict the failure rates, and having a real-time data would help in detecting failures. So I think that would be all.
Okay. Thank you so much for your presentation, and a big round of applause to your team. Next, we'll take a few questions from your judge. Sheon, would you like to go ahead and ask questions?
Yeah, maybe I don't know if you can hear me.
Yeah, I can hear you.
Right. Maybe just a few questions. Uh, I see you talked a lot about the imbalance in the data. Well, I don't really see where you addressed that. Maybe when you try to balance the data, or maybe you don't talk about it.
So basically, regarding the imbalance, what we mostly did was try to actually understand the data in terms of the metrics, right, and feature engineer it to actually, because I believe the data is right. So we did mostly feature engineering and use logarithm where the data was actually imbalanced. So to predict the failure, basically to have it to have a better prediction.
Because the way I think about it is, first it is to set a baseline. Say, if you are using maybe a non-machine learning approach, say just a baseline to say what will the basic model predict, then see how to improve over that. Because if you have 0.1% of the data being another class and the rest being 99%, it means any model will reach the accuracy of 99% on the goal. So say you did set a baseline and you tried improving from there. I think trying to address.
Yes, I think our baseline a bit. Okay, sorry, please continue.
No, please go ahead. It looks like you're trying to say something that you didn't say earlier.
Our baseline model was logistic regression, and it was with that we then tried other algorithms.
Okay, that's what you said. But did you say did you try balance the data to say upsampling, or which mechanism did you use? Say, still you try?
We
Okay.
Yes, go on. You you are trying to complete
Oh, did you already get my question? If you already did
sentence. Sorry.
something well.
No.
I'm just asking for the exact balancing approach you used. Did you try to double the amount of the class that was shot in the data, or did you reduce the class of the ones, or how did you handle data imbalance? You just mentioned about the
Sorry,
modeling.
we didn't do that.
So, if I understand
Yeah,
that,
we just checked
what
the logistic regression and
Okay,
Okay.
I see Tara's hands up, but if I understand correctly, the team found out that the data was imbalanced, but decided to do feature engineering to look at other features that might be able to um, like be less imbalanced, and then continue to run the algorithms and try to see if they can reduce the accuracy. And now they go to a world where they are fine with the imbalancedness of the data sets. This is what I understand. But I think what we're trying to show direction is that, like, you know that your data set is imbalanced, and then you have trained the model, you see you have this accuracy. First of all, accuracy is not a good metric for an imbalanced data set. You should definitely look at other metrics like the F1 score, precision, recall, area under the curve, average precision score, and so on. So I just wanted to mention that in case you did not know about that. When you have an imbalanced data set, do not use accuracy as your metric. It's not very informative or informative at all. You can also look up something called accuracy paradox to better understand what I'm trying to say. Okay, so another approach to go about it is that when you now seen that it's imbalanced and you want to improve it, you can look at methods to that can help you oversample the minority class, such as the SMART and this is some of the metric approaches that I believe Sean was asking you about, that I don't think you delved into. So those could be like a nice next direction to see how to better resolve that issue. But I'll give the mic to Tayo, then to Kenichi.
So you've touched on the biggest part of it, which is the data sampling, the imbalanced data sets, basically. It's never enough. In fact, whenever you're getting any type of problem and you're getting 99 in the upper 90s in terms of performance metrics, something is wrong, because you shouldn't be getting that high. I know there are some use cases, but for situations like this, and I would say the majority of the problem, it's like Tedros said, it's coming from the imbalance in the data. Because what it means when you're saying accuracy is, it's if you had 100 samples of the failure class and 10 samples of the non-failure class, out of 100%, if you get all the failures correctly, then you're going to be getting close to 100% in terms of accuracy. But that doesn't tell the full picture, because it means when it sees non-failure, actual failures, it doesn't recognize it. And hence the reason you need to work on the balance. And she has mentioned most most used algorithm for setting out to balance your data, which is smooth. I think the other question is, so while I like the idea of this whole problem, which is basically looking at machine performance, early warning systems, and so forth. However, how robust is first, where is this? What kind of machine gave you the data, and how robust do you think this solution could get, such that any kind of industry, for instance, because again, I noticed that the language in the problem is industry, no specificity. So how does this become robust such that it's a plug and play solution for any industrial setting? It's okay if you don't have the answer right now. It's a concern, and it's just something that I would like you to start thinking about if we're looking at ways to move this from where it currently is.
I think I can.
Thank you so much for the recommendations in terms of the oversampling. Actually, we took up this project quite very late, and we were trying to do as much as we could to be in this meeting, in this prestige meeting. And yes, I must admit that we have a lot of work after here to just continue and to make it better. Based on the question given, it was also a challenge that we met at first. I'm trying to answer the question regarding the plug and play in any industry. Basically, we need to understand get metrics that would explain better. Maybe in this data, metrics 1, metrics 2, metrics 3, 4, 5 were used, and I think it was what was confusing to us as at first, being beginners. So we didn't know which one was temperature or which was which. The solution could be getting the definitive attribute to each of the metrics in order to be able to go live and put it out there for everyone to use. This is a solution to us that would in the future implement, and I know with that would make a much difference.
So, okay, we'll quickly take the last one from Kenichi, then we'll go to the next presentation and thank Team Interlight again for their work.
Yeah, nice work, team. Right, I like the problem. Right, so I don't think the two questions I had is not too different from what Tayo had mentioned, but I'll just say it in my way. Right, no need to answer, just think about it. Right, so when I looked at the accuracies, right, one of the questions I asked myself is, how do we know it's not overfitting? Right. So when you think about it from that perspective, it will help you do some deeper analysis to check some certain things that or results that you're getting, right? So that's the first bit, right? The second is I was really waiting to hear what the machines were, what type of machines that you were considering, and for what industries, right? So just have it at the back of your mind as you do more work on this. That different machines have different working conditions, right? If you're going to have one big generalistic model, then you should think about what those features should be like, right? I know you got the data from Cargo, I think. All right. So I'm almost sure that there is something that talks about what kind of machines the kind of machines that were used. If you just gathered random data from random different machines in random different industries, right? I can already imagine how difficult it would be to get something that works, right? So that's my few comments. Thanks.
Thank you
But
so
nice.
much. Thank you so much, team. Thank you for all of the nice comments, and we wish you the best for the future work. Next, we would have Simeon give a presentation on behalf of his team, which is himself. So this is our only solo project and the last one for today.
Good morning.
Good morning, Simeon. Please go ahead to share your screen and please try to stay with 10-minute presentation because we're really, really pushing it.
Yeah.
I'll try my best to do that.
Yeah.
Let me share my screen, please. I don't know if you guys can see the screen, my screen.
Yeah. Yes, please make it full screen.
Okay, sorry, actually. Is it okay now?
Yes, it's okay now. You just need to make it slide. Can you please click on the slideshow so it can be
Okay.
in full screen?
Yeah, thank you.
Thank you.
My name is Simeon Tim Ali. This is my final capstone project. My project focuses on machine learning to understand customer segmentation using IFM and K-mean clustering. The goal is to help business identify their most valuable at fixed and potential customers. So this project was designed to demonstrate practical applications for what we learn using data to solve real real business problem. I don't know if my volume clear presently.
It is good.
Okay, thank you. I thought I actually break there. Okay. My project use IFM metrics, which is recency, frequency, and monetary to segment customers that applied K-mean clustering. Then apply K-mean clustering to group them into meaningful categories. The insights can be used by marketing or sales teams to focus on the right customers at right time. Most business treat actually the problem statement. My problem statement is most business treat all customers equally. Everyone gets the same emails, the same offer. The marketing team actually, when they are marketing their business, they treat the customer equally, all of the customers, the same email, the same offer. So this leads to wasted marketing budget and lost opportunities. The problem I'm solving is how can a business use the data to identify who is top customers, who the top customers are, who might chunk soon, who might stop buying, who might stop patronizing the business, and who can be re-engaged. That's where the segmentation comes in. Then the data set. Data set use stimulated retail transaction, basically sale record with customer ID, purchase amount, and date. From this, I derive key RFM features that summarize each customer's behavior. Even though it's generic data set, the method and insights apply directly to real-world businesses. Future engineering RFN model. RFN actually stands for recency, frequency, and monetary. Three metrics that describes how customers behave. The recency tells how recently they bought, lower is better. Frequency tells how much they buy, which higher is better. Then we have the monetary, which tells how much they spend. And in this case, the more they spend is actually better. These three features become foundation for clustering customers into meaningful groups. Modeling approach. So before applying K-mean, I scale the data to ensure that all RFM features contribute equally, since K-mean is sensitive to magnitude difference. Then I tested multiple values for K, the number of clusters no longer improved performance significantly, and the Charlotte scores helped me to confirm which number of cluster produced the most well. This is the elbow that I used. I actually used 8 clustering sets from 2 to 8. Then when I did the model, I got, using the elbow method, I got the best K to be 4. And I also used the Seurat score, which I also got the best K to be 4 again, which higher is better for Charlotte. Then I did the personal mapping using this RFM modeling segmentization. K-mean gives numeric clusters, but numbers alone don't tell a story. To make the result business friendly, I assign each cluster to a personal name. For example, champions, which buy often, spends the most, and purchase recently. We have attributes, customers which haven't bought in a while. We have hibernating customer, might be inactive entirely. Then we have the loyal customers, which they are the frequent buyers, even though the money is not high as champion, but they spend and they purchase frequently. Then I also use the data exploration to validate clustering results and visualize customer patterns. After clustering, I conducted an exploration data analysis to better understand each group. The goal was to visualize how these clusters differ in terms of recent spending, and purchase frequency, and confirm that the segmentation makes sense statistically and visually. Then the segmentation distribution, when I did the explorating data, here is the distribution of customer bases. Right? The majority of customers are either promising or at risks. This tells us that while we have strong potential customers, larger portions of them are also slipping away, which highlights an opportunity for marketing to focus on retention. Then I also did customer counts per personnel. I also exploration data analysis. This visualization showed the number of customers in each personal group. I actually have a data set of 1,000. Yes, so when I did the exploration with customer counts per personnel, it shows that each personal group result. From chart, we can see that the largest customer segment are at risks. Then which at risks and promising, these are the largest customer count. Then it follows by loyal and champion. This means that, and also notice that the hibernating we are zero within the 1,000. There was no hibernating customers because all of them actually have a frequency count of 1. This means that while we have a solid base of loyal and high-value customers, a significant portion of customers are either showing early sign of disengagement, which is at risk, or are still developing their relationship with the business, which are promising. The smaller share of champions indicate that only a few customers make frequent, high-value and reset punches. They represent our top-tier customers. Having many promising customers is actually a positive sign. It shows potential for growth if we can engage and convert them into more frequent buyers. On the other hand, the at-risk group should be a priority of the marketing team because they are the verge of becoming inactive. If not re-engaged, they could move into hibernating segment over time. Overall, this chart provides a quick overview of customer base structure and highlights where to focus retention and engagement. I also did the average recency frequency and monitoring by personnel. If you notice the chart, the blue is for the monitoring, the green is for the recency, and the orange is for the frequency, but there is no orange because my data also is having a little bit problem by the frequency level. The data that I took only has a frequency of 1 for all customers. So this chart shows that champions, loyal customer purchase more recently and spend significantly more than others. At risks and promising customers have similar purchase frequency, but much higher recency, meaning they haven't bought in a long time. The key insights using this, the key insight tells a clear story. Champions and loyals are our main revenue drivers. We have to keep them happy. At risks, customers are critical. At critical point, one campaign could bring them back. Promising customer need encouragement to buy again, whilst hibernating might require a win-back campaign. So using the data and after doing the model and segmentizing the data and giving them a personal name, I actually came up with the recommendation and the business to help the marketing team. The next step is learning is keep the best customer by rewarding them, reconnecting customers before they turn first time buyer into loyal ones, and overall increase repeating buying through loyalty program or bundles. They are actionable data backed strategies any business can implement. The tools I use are Python, the libraries, pandas, NumPy, scikit-learn, Seaborn and Matplot for visualization, Google Colab for development, and the data set I took it from Kaggle. I actually use RFM and K-mean, which is the actionable segmentation that I use. I identify five customer group, which are the champions, the loyal, using my model, the champion, the loyal, the tricks, the hibernating, and the promising. And this framework actually helps to guide the marketing strategy and retain customers. So my next step using this project is looking at this project can be involved into real application. I plan to deploy it on a streamlined dashboard because of time and because I was actually the only one, and due to some personal things that I was going through this time period, I was unable to do. So after this, I plan to actually deploy it to streamlined dashboard where marketers can input, and also plan to enhance the model with demographic, that's gender, age, and then I also the geographical data, and also plan to improve my data because this is just a generic data that I use. I didn't use any business, the real world business data. I just use this to get the model and see if it's possible. With this now, I can use data that has enough customers, enough frequency, then the increased amount of money, then the days, which can also help the model in terms of segmentation. Acknowledgement. I like to thank AI Saturday as always, ML Flip Cohort 9. I also like to thank our facilitator, Yamifide. Sorry, I don't know if I pronounce it well because he has been with us since. Although sometimes I actually miss the class, sometimes I actually watch later, and I actually thank StageMate because of your guidance too. It helps me to understand, although I have a lot to do, and the mentors and the community members. Thank you all for your attention. I'm happy to take any question about the project and the data or the process. You can also connect me on my LinkedIn, which with time I will be after in updating the improvement that I will be doing to this project, and also what and my journey through my machine learning journey. Thank you.
Thank you so much, Simeon, for your presentation. And I just wanted to make a note that Simeon is actually not our cohort. Like, it's not the first time you're taking our cohort. When we had a chat the first time, he told me that back in 2018, I think that was cohort.
2020.
Or
Sorry.
2020, was that cohort 4 or
Yeah,
cohort?
I think for the time when the lockdown
Started.
yes,
Like that was his first cohort, and this was the project that he was supposed to do, but could not finish due to some reasons. And then he decided that he wanted to do it again. So this was, I thought that was really inspiring because some of the instructors from those cohorts are also on this call. So great job. And Simeon is also from Sierra Leone. So it's like we mostly have a lot of Nigerians in our community, in our cohort. So it's really nice to see that we're starting to like have more more Africans within, and I hope that we have even more for future cohorts. Looking forward to working with Simeon also to see how we can support the Sierra Leone community, the AI community. Okay, so any question, Tayo? You're Simeon's judge for today.
So to be fair, I don't have much questions. Thank you very much, Simeon. First, thank you for the project. Thank you for finding us from all the way. Thank you for putting a face and helping us show that we're really Pan-African in what we're doing. Democratization is going beyond where we started from, and this is what we like to see. And ultimately, thanks for this project. This was, I believe, was very well done. I think this type of problem is one of the most practical solutions that you can work on as a data scientist because of the immediate impacts that it could have in whatever way it's deployed. So I am not surprised that I'm seeing that you've walked through it end to end from the problem statement to actual action strategies for recommendation, because like I said, extremely practical as well. So I don't necessarily have questions. I just have, I think, tips and areas for consideration to get this bigger than what it currently is and how to ultimately improve it. So I had this as the second one, but I like that I saw it in the slide, so I'm going to go over it first. Your data, I guess we can all agree that because it's cargo and it's retail and possibly the sensitivity of the type of data it would be, you probably wouldn't get enough, you wouldn't get rich data. I saw your notebook, there's about only 8,000 rows. So it's very likely this is what you would come across for this type of data out there. So as a feedback to improve this, we're going to have to look for more data that's richer than what we currently have, and incorporating other forms of data. So I like that you already included demography and product type, because that's one way to improve it. But also you're looking at geographical information. So, and where I'm thinking is, or how I'm thinking about it is, think organizations, outlets, or sales people that have operations in, so say Nigeria and Sierra Leone, for instance. Different markets have different behaviors. So we need to start building models that would actually consider those nuances, hence the reason those type of data should be collected. So basically the entire strategy I'm talking about right now is expanding the amount of data that is collected, but that is for future work. Other things would be like, so beyond just segmenting the customers, you could look at computing other metrics like related metrics. You had mentioned churn rates, so churn rate, retention rate, customer lifetime value, all those metrics that work within marketing campaigns and so forth. So we could look at computing all of those and actually making actions and strategy conversations around those. And then ultimately, once this starts to flesh out into what it could actually be, then you start considering alternate modeling approaches. So like introducing either Gaussian mixed models or Bayesian approaches to help with prior information so that I can inform future future behavior as far as campaigns and this whole modeling is going. But ultimately, very interesting, very interesting project. And if you haven't gotten by now, I'm geeking out on the project because it's kind of like in the area I'm playing as well. So very interesting and very well done. Thanks, Simeon.
Well,
Yeah, thank you very much, Taya.
okay. Thank you, Simon. Thank you, Tayo. And I wish you the best for the future. And we're always connected, like I said. This goes out to everyone. So if you have more interest in developing some ideas and you want to involve anyone in the community, all you need to do is reach out, send us your proposal. We'll try to find the best fit between what you're working on and the team. Or I hope in the future we even have a process where maybe you can just share on our Google groups like what you want to work on, and people can express interest or whether or not they want to work together. And of course, we have a Discord channel, which I recognize that it's not maybe used all the time, but I hope in the future we get to communicate more there. So thank you so much, everyone, to the audience for being here and for being such a gentle audience and a patient one, and for all of your very good and amazing and thoughtful questions. To all of our judges, we are very thankful for your time. We do not take it for granted at all. And I just wanted to, spend the next hopefully 15 minutes to 20 minutes about like to wrap up the cohorts. This is our last meeting together as cohort 9, and it's really important that we take the time to just let that sink in and also share a little bit about how we're feeling. Of course, we will send you feedback form, but I want to take this opportunity to just ask some of the students from the cohort if they would like to share their experience. We can take 2 to 3 on the call for time sake, but if you don't mind, I would love to hear from you. So anyone can unmute and speak.
Okay, let me go first.
Okay.
Please, Sakura. Okay, so thank you, Teju, for this privilege. Thank you, the whole trainers, the lecturers. So for the very first time, I was thinking, most of when I see content, made by maybe younger folks, it's sometimes I rush a bit of look for more senior content, but looking through those tutorials, looking through those content, they're quite resourceful, quite heavy. Those the YouTube videos, they actually cover a lot. So it's I could see people that they are well versed in what they do. They have good understanding, even the way they explain it, explaining complex concepts. So I was quite marveled. I can see such good resource from young individuals, and that actually got to stem me up as well too. So from my experience, so this is not my first AI Saturday, AI Saturday. So I've been coming around like that, but hopefully I was able to stay true in this one too. It hasn't been easy, but say keeping up with the work and the weekly tasks has not been easy per se. Then also working in the group too has not been easy per se, but it has been wonderful experience per se. So I'm happy to be part of this community once again. I'm looking forward to be more involved and also grow together. Thank you.
Thank you, Abiola. So we have a lot of former students here. Thank you. I've thoroughly enjoyed this cohort too. It's also the first cohort that I spent like a lot of time with all the teams, just chatting about their problems and their projects, rather, said problems. Yeah, the problem they want to solve. And before, in previous years, I would have maybe 1 or 2 teams that I'm only mentoring. But because we did not think we were going to introduce mentors for the projects this year, this cohort. So it was like a very late planning. So I was just like, oh, you know what? I'm just gonna be everyone's mentor. So it's, I think this is I've really enjoyed it. I've enjoyed just hearing about what you're talking about and looking at your project and then providing a little guidance along the way. So thank you for showing up, and I hope that in the future you would also be mentors to other teams and you would share with them your expertise. So I really love our growing community. Anyone else want to share tell us about their experience with AS at this Lagos Cohort 9?
Hello?
Yes, Chitom, go ahead.
Yeah. Thank you once again for this opportunity, like to the whole AI Saturday team. So when I started this cohorts, because I started one time, I think the cohort hit one. I actually signed up for it back then. Yeah, but at some point because it was clashing with what I was doing at that time. So I think I left. It was around the same time when they wanted to start the project. It was around the same time I went to camp, NYC camp. So that was where I lost track of all they were doing. But I promised myself that the next time I see any AI Saturday opening, I would try and come through for it. Yeah, so this particular experience has actually been, will I say, bittersweet, but all in all, it has been a very good one. And coupled with the fact that the people that try to handle this, even though it's a flipped cohort, but the people that try to carry us along were actually people that were always there for us, trying to like help us if we have any questions, feedback, things like that. So it was a very interactive one. And no matter how like maybe a lot of people didn't make it to the end, but I'm definitely sure that people got one or two things from the whole cohort. And I'm really appreciative of this experience, and I'm also interested in the like going forward because I think I had on my last call with Teju when she was talking to our group. I think that was part of um, the conversation that also took our time on the call. So I just feel the learning never stops here, and it's always good to like try and do something more, like contribute, and with better engagement, like everybody trying to do well, like us being the students or scholars in this cohort, like trying to do more and also trying to give back in whatever way so that this AI Saturday can become a bigger one. That's all I feel. Thank you.
Thank you so much, Chitam, for that. So we'll take one more, then I will try to conclude with a few, like 2 or 3 slides. Do we have anyone else who would like to tell us about their experience? Maybe a female? No pressure.
Hello.
Yes, so thank you.
Good afternoon, everybody.
Good afternoon, Precious.
Thank you. I'm so happy to even get to the end. I mean, when I started, I was battling with my PPA, running over and everything. So it was stressful. And then when I got back from NYC, I was coupling jobs with the whole cohorts and stuff. But what I kept doing was watching the video, even when I don't understand, and trying to finish the assignments on time, even when I don't know what I'm doing. So I'm just happy that aside finishing uni and NYC, I've been able to finish something, start from the beginning and get to the end and actually finish it. So that means there is hope. So I'm very grateful to AI Lagos. I think AI Lagos was introduced to me to a senior colleague in school. She came to talk about, because I studied math science in University of Uyo. So I had a senior colleague. She came to talk about thing. Okay, we had a conference and she spoke to us. I think she was studying in Germany at that time. So when I reached out to her, she told me that there is a cohort I can join. And then I was writing my final exams. So when I started it, the timetable came out. So I couldn't just run down my finals for the cohort. So I left it and just finish up school. So since then, I was always asking. I think I sent a mail to Teju requesting for an update about any cohorts because at that point I was very free. Then when this one came up, I think you sent me a mail for me to register. So although I was just contemplating, but I'm just so happy that I got to the end. So thank you so much. I'm happy to be here and I'm happy to learn more and go further. Thank you.
We are so proud of you, Precious, and we are proud of every one of you. Needless to say, it's very difficult to stay with a course for 4 months, and I know that, and there's no judgment to anyone who was not able to pull through. And as you can tell from past students like Simeon and also Chitom, you can start and say, oh yeah. I don't think I can manage this time around. But we're still here. You come again the next cohort and you put in your whole and you're in a different position. So this is what I love about community. Because there's no judgment. It's just that we are here to support one another. But of course, if it's also an opportunity to push yourself, to try to get to the goal that you've set for yourself with other people doing it at the same time as you are, and to learn from one another. And I also really hope that the project experience has helped you make friends, and that would be lasting forever. And this is how one of the ways I make friends is through my projects and collaboration. And some of the people that are still my friend now, it's because we started ASD together back in 2018, and I think they're stuck with me forever. I hope so. But when we started, then I didn't know that we would be having this long relationship journey like ahead of us. We were just really excited. 20-something-year-old now, we are excited. 30-something-year-old. So we're getting very old. So to conclude this cohort, I just wanted to again thank you all for being here, and of course thank you Omife for the incredible commitment that is put in. It's not easy, y'all. Like when you see him, you say thank you to him. He has tried to organize the entire cohort. I've been his advisor on this journey, but he's been putting in a lot of the work behind the scene. So he's created all of the assessments, he's created like attendance sheets, and he's collected the attendance, analyzed it. And then, these are some of the statistics that we collected from the first week that we started the cohort. You can see we had over 74 attendants until the very last week of learning content, where we had like about 20 something, 24 like on the call. So it's not surprising to us that we have this. We have this low you start very high, and then you have it tip off, but it understand life happens, but we always hope and champion the people that dropped off would come to the next cohort, or we find ways in the community where they can continue to learn and improve themselves. So in order for you to receive a certificate, we have outlined some criteria in the beginning of the cohort, which is that you need 60% minimum attendance at the community calls, unless there are some exceptions where maybe you told us that something happened in the week, you couldn't attend beforehand, so then we would have taken note of that. And then we want you to have like 40% average assessment score. And then this project is non-negotiable. So you can already know that if you presented your project today, you're almost certain you would receive your certificate, unless for some reason you did not meet up with this other criteria, which we hope that is not the case, because you really worked so hard to get to this point. So we will be sending you the certificate within the next week. So expect that in your inbox, and we'll be sending you to give us your feedback and so on. Once again, this really is always a team effort with I am because we are Ubuntu. So we're very, very thankful to our Cohort 9 flipped team led by Yomife and myself. And then we had people that supported us in social media early on in the cohort. Sharon, also advised by Tola. And then we have like other members of our core team who were also part of the brainstorming to structure the cohort. Ibrahim Ghana, Kenichi Duko, Femi, and also Simon. So I want to say a big thank you to all of our support and our team for cohort 9 flipped. And I would also like to thank all of our cohort 8 instructors, judges, tutors, everyone that made cohort 8 happen, because of them, we have a resource that we could point our cohort 9 students to. So we want to say a big thank you to our teaching staff. And yeah, I'm sure Yomife here. I'm going to also allow to say a few concluding words to you before we wrap up for today. So Yomife, would you like to say something?
Yeah, it's been a privilege serving with the community, and it's been a privilege also working with Seju. I this it came as a chance and opportunity, and I'm glad I took the opportunity to work with the community and also work closely with Seju. It is an experience I do not take for granted, and I am glad about that. I am a part of the community and I will always be a part of the community. And it's been amazing, like, connecting to the network of, of of professionals that are available within the community. And it's been an amazing experience for me. And working with the community at the back end, it has been I've been amazed at the amount of at the number of capable hands that we have here, and I am glad to take the lead on this particular course. I am grateful for that. And I would like to advise our people that, completed the project, that it doesn't end here. This is just the beginning. The projects can be, take all the feedback and further work on it, and, work on other stuff, work on things, and yeah, and do greater things, do greater stuff. Don't be stuck on tutorials, work on projects, push yourself, and the community is always there. Because we finished this course today doesn't mean we shouldn't interact on the channel. Let us keep the channel alive. Ask your questions, tag whoever you want to tag, and you already have friends you can collaborate with as well. Collaborate with people, and feel free to reach out. If you want to reach out to me, I'm available. If you want to reach out to Stage, you know where to reach out to her. And thanks to all our judges. It's nice seeing it's nice seeing a couple of familiar faces here. I have met with a couple of people here at the back end. I've met with I've spoken with Stola. I think I've interacted with Mr. Tayo Jabbar on some cases. I've also interacted with Mr. I think he dropped off. Mr. George. Okay, sorry, Mr. George. Yeah, it's been nice knowing and interacting with everybody AI Saturday. Yeah, sorry if I missed anybody else.
No
So
worries.
yeah, thanks so much, AI
So,
Saturday, for having me.
of course, Yamife. Thank you so much. And I just want to give you like a last to do. Make sure that we are connected forever. So make sure you have our Discord. You're on the Discord. Make sure that you're on our Google groups, because that is where we send all this information to about jobs, about the new cohort that is happening. Also follow us on all of our social media to stay connected, and you can add our calendar to your calendar, which you will see if there's, like, say for example, a community call happening in the future, which we hope we would start doing, maybe like a monthly check-in or something, or like there's a colloquial talk, which we would of course advertise on social media. But if you had our calendar, you can pop in and pop out whenever you want. So I just wanted to say thank you again, and let's take a family picture, and then we can call it an amazing cohort. But if you don't mind, please open your camera to take a picture together. And so we can keep this everlasting memory. Okay, so we're just gonna wait for a few more people to turn on their camera. Oh, look at those faces. Okay, so do we have a few more faces that we can see? Okay, Chiton, thank you. It's okay, no pressure, but in case you're able to, there's no judgment here. Um, okay, so I think that's mostly it. Does anyone else want to put on their camera before I take a picture? See Tola. Okay, so let me start taking a few, then if we see if more people join, then please someone else should take a picture just in case just in case like one of those photo got lost. All right, let's do cheers. 1, 2, ready, go. Say AI Saturday Lagos.
Sorry, I always submit ourselves.
No need. Well, thank you so much, everyone. Great to see you. And thanks. Enjoy the rest of your day.